Hello YouTubers, welcome to my YouTube channel. This is Uncle Pythagoras signing in. Today we are going to do momentum. We are going to take this paper from Mpumalanga. I think it's Mpumalanga. Yes, we're going to take it from Mpumalanga. This is question paper from MP. It's September. It was the trial for last year, September 2023. The question is question form. Right. The question reads as follows. A tennis ball with a mass of 115.5 grams strikes a stationary object of 8.45 kilograms block with a speed of 45 meters per second. And it bounces straight back with a speed of 10.6 meters per second. The block moves 1.32 meters to the right as indicated in the diagram below. Now we are going to draw this here. This is our surface. This is our tennis ball, which has been struck at a velocity of, we will say this is initial velocity of the ball as 45 meters per second. It comes to strike let's see, this is our block. The stationary block of 8.45 kilograms. Then the block start moving. This is the initial position of the block. Let's say this is the final position of the block. The block will be here. The block will come to this place. Let's say this is going to be a virtual object because this is where we imagine it to be. It will be virtual object. Now the distance from here to here where the ball has gone, it's 1.32 meters. This is our tennis ball. It was hit by a racket. It travels at 45 meters per second. It hits the block. The block will start to move. It moves a distance of 1.32 meters. Then, this is the information that we are given. Now the question follows, 4.1. State the principle of conservation of linear momentum in weights for 2 marks. This is a theory that you need to know that you need to know this. The total momentum of the isolated system remains constant. This is your 2 marks. The next question is 4.2. Calculate the magnitude of the 4.2.1, the velocity of the block immediately after collision. Calculate the magnitude of the velocity of the block immediately after collision. Immediately it bounces here, we must calculate that. So the formula for the momentum, we are going to use it as, right, the sum of the momentum initial is equal to the sum of the momentum final. This is the formula that you are going to use for this. Then we have, let's indicate the mass of the ball, let's say tennis. The mass of the tennis multiplied by the velocity of the tennis initially plus the mass of the block, let's say B, multiplied by the velocity initial of B is equals to the mass of the tennis for the final velocity plus the mass of the block multiplied by the velocity of final. Now the question says calculate the magnitude of the velocity of the block immediately after collision. Immediately after collision, so this is what we are required to calculate. This is what we are calculating. So now the mass of the tennis ball was given as, the mass, we did not write the mass. The mass of the tennis ball was 15,5 grams. So before we can do this, we must convert everything. The grade 6 learners will tell you that to convert from grams, here we must start with biometric conversion. One kilogram is equals to 1,000 grams. The grade 6 can quickly go through this at ease. How much kilogram will be a 15,5 grams? You cross multiply, and then this is what we call a, what concept is this, by the way? It's rate and proportion. We have done this at grade 6. Now we need to calculate how many kilograms are there. We know that is going to be 0,0155 kilograms. I was just showing you how did we arrive to this one. Now we are going to apply this mass of, here we come here, 0,0155 kilograms. You multiply that by the initial velocity of the ball, which is 45 meters per second, plus, okay, due to the constraint of time, we are going to continue here from this question 4.2.2 in the next video. Thank you very much. Like and subscribe my YouTube channel.